Bryce was diagnosed when he was 2.5 on Christmas Eve of 2002 with a very bad cancer called neuroblastoma.
And it was during his stem cell transplant that he lost the majority of his hearing.
All I remember is like right when I was ending, and and just coming out of treatment, not being able to hear anything. And I said to my mom, why have other people stopped talking?
I've spent a long time doing the research on where they're working on curing hearing loss. And Stanford stands head and shoulders above anything else that's out there. It's the only place that I've seen that has really brought together a critical mass of people.
As far as I know, my hearing loss came about because of loud music. When I moved in with my future wife, she kept having to repeat herself, which became really frustrating for both of us. I tried to correct my hearing loss by going to an audiologist and having a test. And they found out that I had a severe loss of hearing, and it needed to be corrected with hearing aids. I had to learn how to hear all over again, and that was quite a lifestyle change.
We found out she had profound hearing loss in one ear and severe hearing loss in the other. So it was a very big shock.
When Lily first failed her newborn hearing screening, I guess the first feeling was just total denial. I mean, there's no reason why our child shouldn't be able to hear. All these things kind of go through your head. You know, what's her wedding going to be like, and how is she going to take care of her own children if she can't hear them cry in the middle of the night? We all just did as much research as we could and came upon Stefan Heller. It was very exciting for us to hear about what he was doing and what other scientists were doing, and that there was hope.
When I think about hearing, it is essential to what is most elemental to humankind and to human society, and that is the ability to communicate with each other, to share our ideas, to share our emotions, to share our knowledge, to teach our young, to communicate with each other, to learn, and to join us together to common purpose. You know, in the last 10 years, here at Stanford and elsewhere, but we have built the ability to regenerate tissues. But in particular, we have become quite advanced and very promising in our ability to regenerate the sound sensing apparatus of the inner ear. And the current state of the science and the technology is such that we are hopeful that in the coming decade that we will be able to launch the process by which a deaf child can be treated to restore the lost elements of the inner ear essential for hearing, and to bring them to a normal life with hearing at a normal level.
Hearing research is a very small field, and small advances in this field can make a huge impact on quite a number of patients. But for achieving these small achievements or larger achievements, we need to collaborate.
At Stanford, we have well over 50 scientists working together towards curing deafness. Now, why is Stanford uniquely the right place to hold such an initiative to cure deafness? Well, the reason for that is that we have so much here that integrates to this purpose. We have the world's largest and most innovative stem cell and regeneration community. We also are widely recognized as being further ahead in a broad number of biologic and technique methods in terms of regenerating the inner ear.
The main goal of our initiative is to cure hearing loss, and we aim to do this by assembling the best and brightest bioscientists, engineers, and clinician scientists of the field at one place, at Stanford, and to create an enabling environment for them to work best at the peak of their careers, to work together and to do something that's really, truly unprecedented.
We feel that through regenerative means that we can restore the lost sound sensing cells within the inner ear within the foreseeable future that will allow us to overcome a wide variety of inner ear diseases that cause hearing loss and deafness that at present are completely incurable.
We're starting to get to the point where we can see specific damaged areas in a living inner ear that can tell us not only why that inner ear isn't working, but what would be needed to restore function in that specific inner ear, which is very exciting.
There are occasional times when very major initiatives come up. For example, the cure of polio, for example, the cure of smallpox, where a category of human suffering can be fundamentally altered and overcome in a period of time through a concerted effort.
We are a small field, and this small field can have a huge impact on a large number of patients. But it requires collaboration of many people from different fields, bioscientists, engineers, clinicians. The field has struggled for funding, and one of the main reasons for this, in my mind, is that it lacks a lobby. There are large lobbies for larger diseases like autism, Alzheimer's disease, life-threatening illnesses, cancer, and so forth. Hearing research has not had this large lobby.
I believe we're on the verge of something really special and very consequential. We have the possibility of overcoming hearing loss in a way that will fundamentally change one of man's great disease processes.
What would it mean to you to have a cure?
I don't know, it would just change my life. It would just be like a 10-ton weight just lifted off your shoulders. That's how hard it is.
A cure for hearing loss would be wonderful. It'd be so much better than having to wear hearing aids.
We're absolutely thrilled to be a part of the Stanford Initiative to Cure Hearing Loss, and not just because it might have an effect on Lily, but it's just so thrilling to us, the number of people that it will affect.
Over the coming years, we hope to really achieve the goal, which for us is to make deafness gone as far away as polio is today, and to overcome this disease categorically so that no one has to suffer the isolation or limitations in their ability to enjoy communicating with their family and friends and coworkers.